In this video, we're going to cover differentiation. We will be looking at the chain rule, the product rule, the quotient rule, rates of change, and that includes average rate of change as well as instantaneous rate of change. On your screen are the formula. It is a good idea to write this down to remember it. To begin, we'll start looking at a question here where we need to differentiate the following. So remember, I'm going to write this out first. When you differentiate a function, the power is brought out the front as a coefficient, and then you minus 1 off the power. So our 4 will drop down the front, the 3 drops down the front, and so forth. So we're left with 3 times 4, x, 4 minus 1, 2 times 3x, 3 minus 2, minus 1, sorry, plus 7. Because that only has an x by itself, the x disappears, we're left with just the coefficient of 7. And the minus 4, because it doesn't have an x value, it disappears as well. So we're left with dy dx and y equals. So 3 times 4 is 12. So x to the power of 3, take away 6x to the power of 2 plus 7. Here we have another question. We're going to write it out. Before we begin, we need to make sure that we have the x to the power of 4 on top. We don't want to have it as a fraction. To do that, remember, if your x to the power of 4 is on the bottom, it has a negative power. So x to the power of negative 4, and then we can differentiate it as always. So the negative 4 will come out the front, and we get negative 4 take away 1. So negative 5 times negative 4, x, negative 4 take away 1 is negative 5. The question was given to us as a fraction, so it's a good idea to return it to a fraction. So 20 over x to the power of 5. Next, we have an example of using the chain rule. I like to show y equals 7x minus 2 to the power of a half. Remember, a square root sign is a half, a cube root sign is 1 over 3, etc. We let our bracketed area equal u. So u equals, we'll start with y equals u to the power of a half, and u equals 7x minus 2. So we differentiate each of these. Now we use our formula that was up here, and we multiply our dy over du by du over dx. So dy dx will equal 1 over 2u to the power of negative a half times 7, which will be 7 over 2u to the negative a half. We can replace our u, so substitute our u back in. Remember, u was 7x minus 2. So we have 7 over 2, bracket 7x minus 2 to the power of negative a half. So the negative indicates that the 7x minus 2 will be at the bottom of a fraction, and the half indicates it will be a square root. So we will have the square root of 7x minus 2. Next, we have a product rule where u is our front and v is our bracketed area inside. So u equals 4x, v equals x squared plus 1, du dx equals 4, dv dx equals 2x, and then we can use our formula here to find the differentiated equation. our v was x squared plus 1. I like to have it in brackets just so I'm separating out its parts. And we're multiplying that by 4. Then we have our 4x multiplied by dv over dx, which is 2x. Essentially, it looks like we're multiplying in a cross method here. So we're left with 4x squared plus 4 plus 8x squared. Look for your like terms, which are both our x squareds here. So 12x squared plus 4. Now we have a version of our quotient rule. So where our u is on top and our v is on the bottom. So we do a similar thing to what we just did previously. X squared plus 3, v equals 2x minus 3, du dx equals 2x, dv dx equals 2. We then use our formula. So dy dx will be our v, so 2x minus 3, multiplied by dy dx. Sorry, that's meant to be du dx, which is our 2x. Then we go minus our u, x squared plus 3, multiplied by 2. And this is all over 2x minus 3 squared. So we're left with 4x squared minus 6x minus 2x squared minus 6 all over 2x minus 3 squared. We have some like terms here. All right. Next, find the gradient of the tangent to the curve y equals x squared minus 2x plus 5 when x is negative 2. So the tangent, remember differentiation is also known as a gradient function. So we start by finding our differentiated equation. So dy dx is going to become 2x minus 2. We then know, so remember over here, dy dx equals m, which equals gradient. It's important to remember that. So now that we got that, we can say, well, let's let x equal negative 2. So our 2 times negative 2, take away 2. Negative 4, take away 2, equals negative 6. So our gradient for the tangent is negative 6. Now, if you were told to find the normal, remember for a normal, you have m1 equals negative 1 over m2. Find the formula for the rate of change dq over dt given this. So remember, rate of change is also just the differentiated equation, so we can just differentiate this. So dq dt will be 6t, and that's it. Alright, and that's all you have for that one. Now with this, it's assuming it's instantaneous. Remember, you have two different types. You have instantaneous and the average. The average is just y2 minus y1 over x2 minus x1, and instantaneous involves differentiating an equation. So to end the video, we'll do a quick recap. On your screen are the chain rule, the product rule, the quotient rule. It's important that you remember these and have these written down. It's also got your rates of change. Remember, your average rate of change involves y2 minus y1 over x2 minus x1. Your instantaneous rate of change is the first differentiation. Finding the gradient of the normal is -1 over the gradient of the tangent. So the first step in these type of questions is to find that gradient of the tangent first by differentiation. You'd also note that velocity is found by using the first derivative and the acceleration is found using the second derivative.